you to do lab 3. Lab 3 is on page 36. I just want you to turn to that page. If you could just now focus on this particular lab, right? So lab 3 is actually, it won't be as easy as lab 2 because we have to cover more material here. But still, it's a pretty straightforward lab. This lab will focus mostly on the box plot graph, which is, I mean, this lab is almost entirely devoted to one type of graph called the box plot. And we'll be using the smoking data set to motivate the box plot. And so I want you to turn to page 36, and we'll get started with the lab. Question 1, I'll say something about the end of this presentation. I'll leave pretty much question 1 for you to do, but it'll be 1 point. And question 2, the thing that I'll be focusing on will be 9 points. So, and I'll give a little hint about question 1 at the end, and I'll tell you how to get the data set. Okay, so this lab is principally about box plots, so we'll start with question 2. It says, retrieve the smoking data set from iLearn. So you should probably already have that on your desktop. So if you don't have it, you'll have to go to iLearn and look under, I believe it's assignments, maybe, is it? Assignments, right. Okay, so let me just get the data set out from here. So it should look something like that. And it's in the course under iLearn, so you should have it. Just click on it and open that. You'll be working with this data set for this entire lab in terms of question 2. For question 1, I'll make the data set clear later on. Okay, does everyone have this data set open right now? Anyone doesn't have it open yet? Okay, so let me just give you a few seconds to get it from iLearn. This data set is available on iLearn under the course heading for this particular lab. Under assignments. Like I said before, you'll be working with this data set again and again, so it's probably a good idea to put it on your personal folder so that you can retrieve it at will later on. All right, so I think I should start with this sequence of questions. Question 2A says, obtain a box plot of all student pulse rates. So this is a box plot for all student pulse rates. As I said before, we'll be dealing with box plots this lab. So pulse is under which column in the data set? C11. Okay, good. And you just go to graph, box plot. You choose a simple option as before. See, there's almost no variation in what we do here. Simple, you click OK, and then you simply select this pulse variable. Select that, and you click OK. So this is just a copy of what we did for everything else so far. There's nothing new here. And then you get this box plot. Okay, so the thing about the box plot you need to know is that you need to know a couple of things about it. First of all, you need to understand that it's plotted in a particular way. These stars at the top represent data points which are outliers. They are points which fall outside the range, the normal range. So you'll be asked some questions about that. I like to maximize this box plot so that you can see the outliers more clearly. Sometimes the outliers are crunched together, so you can't really see how many they are. And some questions specifically ask you how many outliers there are. So you have to sometimes just maximize. Then you can see it easier. And then if you just move your cursor on top of the box plot and let it hover there, this little box pops up. And this shows you very important statistics. It shows you the Q1 value, it shows you the median value, which is Q2, and it shows you Q3. Those are the most important things that you need. I guess another important thing would be N equals 423. That's the total sample size. But we already know that the smoking data has about 400 elements, or the number of the sample, number of samples in the data set is about 400. But the important things you need to get from this box plot is the Q1, Q2, which is the median, and the Q3. The only counterintuitive thing here is that the box plot is arranged geometrically from bottom to top. So Q1 is over here. Then this is Q2 and this is Q3, right? But it's written the other way around. It's written down, but it's actually going up. Okay? So that's the only thing that you have to keep in mind. So this is Q1, this is Q2, and this is Q3. And you can see that if you read this off, the pulse, you'll see that's around 91. And if you read this off, you see that that's around 73. So that's the only counterintuitive thing about this. So that's one thing you need to keep in mind. Another thing, which is obviously you need to do, is you need to let the cursor hover over the box plot to get this box plot up, pop up. Otherwise, it won't pop up. Okay, so you don't need to know that to solve this question, but for later on, you'll need to know that. All right, any questions on the box plot on this passage? Yes?
Do you consider all the stars as outliers?
Yes. So how many outliers are there in this graph?
5, 7.
5, 6, 7. Yeah. 7 outliers. Okay. Any other questions regarding this box plot? All right, so that's part A. Part B says obtain separate box plots for smoker and non-smoker pulse rates using the same scale. So here you will have a splitting variable. And what is the splitting variable in this case? How? Smoking. So you'll split the sample into 2 separate samples, 2 separate groups, the smokers and the non-smokers. And so that's C6. And we'll again plot the pulse rate, but this time we'll split the sample. So again, we follow the same procedure we did for dot plots and histograms. We go to graph, box plot, because we are focusing on box plots in this lab. And you keep it simple, you click OK. You leave the pulse variable as the variable you're going to plot, right? But then the splitting variable, how do you enter that? Multiple graphs, good. Bi-variable tab, not the multiple variable tab, okay. Same exact procedure. And then in the first box, you select smoke as a splitting variable. And you click OK. And then you get a box plot like that. And then if you maximize that, you can see exactly, well, how many outliers there are. The outliers are a bit scrunched up over here, so. Okay, any questions about that? Yes, sure. You go to graph, box plot. You go to simple, click OK. And then you choose pulse, right over there. And then you go to multiple graphs. You choose the bi-variables tab. Not the multiple variables tab, bi-variables. And then you just, in the first box, you put in smoke, the C6 variable. Okay? Click OK again. Click OK again. All right. Any other questions about this part? This is all we've pretty much done before. It's nothing really new in the procedure or the technique that we follow, right? The same technique was followed for histograms, the same thing was followed for dot plots, and now the same thing is being done for box plots. Same thing was done with dot plots, now same thing is done for box plots. So this is all pretty much the same. In fact, I kind of made sure that everything was the same with the way I taught it to you. Otherwise, there would be some discrepancies here and there. But the way I taught it, it would turn out that it was the same, so it wouldn't create any confusion. Okay, so part C I'm going to leave to you for you to do. Okay, so C is something that's for you to do. I'm not going to be too picky about that, as long as you have a reasonable answer there. D, I'll just do it for you as a review, right? D says obtain the descriptive stats of the pulse rates for smoker and non-smoker students. So how do you obtain the descriptive stats for smoker and non-smokers? When did we do that? Last lab. That's the whole point of the last lab, right? So you go to stats, basic stats, display descriptive stats. This was the one function we learned last time. This was lab 2. And then the first variable is the variable you want to get the stats for. That's the pulse rate, the continuous variable. You select that. And the second variable is the splitting variable, right? You're splitting the whole sample into 2 groups, and then you're getting the descriptive stats for each group. So that is smoke, again, C6. So this is something we did again last time. So the continuous variable is pulse, which is C11, and the splitting variable is C6, smoke. And you click OK. And you get then the descriptive stats for the smokers and non-smokers. So if you look at the key, I think non-smokers is 1 and 2 is the smokers. So what is the mean for the smokers? I just want to write that down for future reference.
79.8.
You agree with that?
Yeah.
You agree with yourself, right? That's okay. But does everyone else agree with that? Yeah. How do you know one is smokers?
On the key.
Oh, it's non-smoker.
Right. Right. So you have to be careful reading the key. Another way you can sort of see that you might be slightly wrong is because the pulse rate for the smoker should be a little bit elevated as compared for the non-smokers, right? The healthier you are, generally, the lower pulse rate you have, right? That's a general observation. So my pulse rate is around 80, but hers is about 60. Okay. So the smoker's mean is 86.48. And what's the standard deviation for the smokers? 16.21. Okay, I'm just plucking those 2 stats out because we need them later on. So that's part D. Any questions about part D? Yeah.
Part B, you just want us to paste this descriptive stats pulse. You don't want us to say which is smoke and
Yeah.
non-smoke. It's understood.
Yeah, because the question doesn't really ask you to do anything other than that. So that would be fine. Right. So if the question were to ask you to comment, then you would have to comment. But even then, you could just write something reasonable. But in this case, you can Simply copy and paste. Okay. E, I'm going to leave for you to do because I just kind of mentioned E. So I'm going to leave that for you. F, I want to do. About, it says, it's a kind of awkwardly worded question here. It says 25% of smokers have more than what pulse rate? So I want to just draw this out for you. Box plot. Probably draw a bigger time. Let's see. So like I said, it goes from bottom to top, right? So this is Q1. This is Q2. And this is Q3, right? So Q3 is the value such that 75% of the smokers are below that value and 25% are above that value, right? Q2 is the value such that 50% of the smokers are below that value and 50% above. Do you see that? And Q1 is the value such that 25% of the smokers are below that value and 75% are above that value, right? So this question is a bit awkwardly phrased. It's certainly a bit awkwardly phrased. It says about, I don't know why you need about, 25% of smokers have more than what pulse rate? So they're asking you, and it's already probably set up. Like that. And then we know smokers is 2, so we just let that hover over there. So Q3 in this case is 95.75. So Q3 for the smokers is 95.75, and that is the pulse rate such that 25% of the smokers are above that value in terms of pulse rate, and 75% are below that value. Any questions on that? It's a bit tricky. But
about
which part about the box plot?
you said the value they're asking for, it's about 20%.
Yeah. See, the value they're asking for is a value such that it splits the sample into 2 parts. 25% of the smokers are above that and 75% are below that, right? So it's a value that splits the sample in a particular way. The median is a value which splits the sample evenly, right, into 50%, right, into equal halves. So this is a value, this value is Q3, and 25% of the smokers are above that value, and 75% conversely are below that value. So the question is a little awkward and imprecise. It should say, what is the value of the pulse rate such that it splits the smokers into 2 groups. One group has, 25% is above that value, and 75% of the sample is below that value, or something along those lines. It should mention the word 75% somewhere so that you know the way it's being split, right? That's a bit tricky. I'd like you to think about that. People have sometimes difficulty visualizing that, but if you understand the definition of Q3 and Q2 and Q1, it should be pretty clear. A G, what percent of smokers have a pulse rate less than 86? Smokers. Remember, we're again still dealing with smokers, right? 2. So it says, what percent of the smokers have a pulse rate less than 86? Now, this is a bit of a trick question. Little trick. So what's 86?
Q2.
Q2. Median, the Q2 is 86. So how many smokers have a pulse rate less than the median?
50%.
50%, right, yeah. So this is a simple question, right? It's a bit of a trick question. Once you realize that Q2 is 86, then the answer follows immediately. That if the median is 86, then obviously 50% of the smokers are below that median, right? Just as obvious, the 50% smokers above that median. Okay, so any questions about this part G? Yeah.
The box plot. So the value of Q2 pulse, which is the y value.
Yes, it's the pulse value. It's the value of the pulse rate, yeah.
So a specific pulse value divides the sample. So that's
Yeah, exactly. A specific pulse value will split the sample up. Like if you arrange all the pulse rates in order of size, then the 50th percentile will be at, you'll reach the halfway sample point at 86. And then the half the sample without pulse rate below that, half will above that. Yeah, that's the right. So it's again an awkwardly worded question, clearly. I mean, the linguistic quality of some of these questions is questionable, right? So anyway, the idea of the question should be pretty clear. It's asking for the empirical rule, and it's asking for a confidence interval, right? That's the right word for it, such that assuming the empirical rule applies, 95% of the smokers are in that confidence interval, okay? So how do we go about constructing that confidence interval? I want to use this word confidence interval because we'll be doing lab 7 and 8 purely about confidence intervals. So this is, in a sense, a precursor to that, or this is just pressing that a little bit. So what does the empirical rule say about 95% of the data? I mean, how many standard deviations do we have to? Two. Okay. And one more thing I want to mention about this question is important because we'll be doing, in part 1, you'll be needing this idea. Okay, so this idea might help you in part 1, in question 1, which is worth only 1 mark again, but it might help you in one of the things that you might have to consider. So we want to construct a 95% confidence interval using the empirical rule. So we want to look at this confidence interval. Again, it's about the mean. So we look at mu minus 2 sigma, comma mu plus 2 sigma. So the endpoints of the intervals are defined by those two expressions. So you take the mean and subtract 2 sigma to get the left endpoint, and you take the mean and add 2 standard deviations to get the right endpoint. Clearly. Did you guys cover how to construct a confidence interval like that in class? Not yet. You'll see that. Okay. So we already know from the displayed descriptive stats that the smoker's mean is 86.48 and the standard deviation is 16.21. So this will be just 86.48 minus 32.41. And this will be 86.48 plus 32.41. And if we subtract that, this will be, I think, 54.07. That will be 118.8. So 95% of the smokers' pulse rates, the smokers, because we use the mean for the smokers and we use standard deviation for the smokers. Remember, we got that out from the descriptive stats function earlier, and I recorded that because I knew this question would be coming up, right? So 95% of the values fall between those two values. So if the pulse, pulse rates above 54 and below 119, 95% of the students should lie in that interval if the empirical rule were to be true. Now, that doesn't mean the sample follows the empirical rule exactly, but if the empirical rule were true exactly, right, then 95%, exactly 95% of the sample would fall within that range. Okay, that's a very important question. Any questions on that? Any questions on that idea? Yeah.
This question doesn't have anything on the computer that you actually didn't document.
Yes.
Okay.
I mean, there's a calculator there you could use somehow, but you have to carry out this calculation. Yeah. Yes, good question.
Check whether we can apply the verbal rules. We have to construct the histogram, see if it's developing.
That's true. To check if the empirical rules follow, you would have to construct the histogram and see if it is a normal distribution. However, the question assumes that it is in this case, but that's a fair question. I mean, it assumes that it is, so you don't have to do that, and you just take that as a given. That's your assumption in the question, right?
In case it's not given, more one.
Yes. In that case, sir, you would have to go through that process.
So when you want us to write this answer in a homework, you want us to just type it out?
You could write it down with your hand, leave a little space and write down with your hand, or you could just type it up in a way that's convenient to you. I don't need to see a sigma there. You know.
Because like that was the question. How would I put the symbol on the?
Don't worry about that. Just use X for it. Use anything for it. I don't mind that. I'm not picky about your.
But we have to show the work out.
Yes, you have to show the working for that. I mean, you just can't put these two numbers up there and expect to get the full mark, right? I want to see how you got there.
Can I write the last two steps without the formula because I want to use the symbols? Yeah.
Yeah, you can show this. Mean for smokers is this, standard deviation for smokers is this, and then do this computation. I mean, anything that shows me how you got the answer right. Some little things there. I won't be picky as long as you show me some way, right? I'm not going to be like extremely picky about it, like, oh, you missed this little step out, so now, no. Okay? As long as I see you understand the idea behind it. Okay, any questions about this? Because this is a key question. All right, so, yes.
Can you please repeat how you found the new for the smokers and the standards degree?
Yeah. That came out in the display descriptive stats function.
Oh, okay.
So it was right here, right? And it was here, 86.48 at 16.21.
Oh, yeah, okay. Thank you.
That's a good question as well. That was basically lab 2. Okay, great. So I and G I'm going to leave to you because it's similar. You have to do a similar thing for non-smokers. Now, question 1 I want you to try by yourself. It's 1 mark, but I will say one thing about it, okay? So, can I erase that? Are you still copying that? Okay, erase that now? This one second.
New, is it the new? Because I want to like write different words instead of new for the first one, like new smokers.
Yeah, I mean, I don't want to get into the details of that question, right? You can write it up in a lot of different ways. Mu is the mean, but like whichever you write it is fine. You can say mean, you can say, you know. It doesn't,
But new is mean, right?
yeah, the mu is the mean. That's a pretty standard notation for the mean, right? I don't know how you guys are called. What do you call the mean in the theoretical lectures?
We just write MEAM.
Oh, okay.
Or
You
like
don't-
an X to the bar on top of them.
Oh, you sometimes use, that's the sample mean, right?
No, but we told this as well, but I just dropped it differently.
Okay.
But I have a longer amplitude.
I mean, if you want, I can call it X. I don't know. If that makes you comfortable. But it's the mean. I guess you guys are not used to notation. I should probably keep that in mind. Hmm.
Okay, I'll just erase that, move on to question 1, right? So question 1, I'll give you a hint for that. I can't go through it because I virtually did everything in question 2. I mean, the main things, and pretty much everything. So question 1, I want you to look at example 1, page 33. I'll just check that. For ideas on that. Yeah. And I want to mention one thing, that it's about a particular data set. So let's just close this Minitab data set and open Minitab again. And question 1 deals with a data set in the sample folder called the Pulse data set, pulse.mtw. And it's looking at only one column in the data set, the first column called Pulse 1. So I'll show you how to get that data set. You go to File, Open Worksheet. You click this folder to populate it. Right, click it now. And then you search. The search function is now active. So you write PU, and you pick the first file, pulse.mtw.
Pulse?
Yeah. It's confusing because we have Pulse as a column in our original smoking data set. Now we have the name of file, then we have another thing called. So
Professor, what did you click for it?
you click this tab over here. That's very key. That's very important. That's a good question. That's a very key tab. You have to click that. That's a very good question. And then you click open, and you just click OK. And you'll be dealing with only the first column for question 1. You'll be only dealing with that column, C1. Okay, that's a hint. The third hint I want to give. The first hint is that look at example 1, example 2, and the second hint, I guess, is that just look at this particular column for question 1. And that's all I want to say for question 1. There'll be 1 point, so not a big deal. Okay, not a big deal. All right, and that's a lab. I'll put the lab 1 over here, and I'm going to collect. I've already taken lab 2s. Okay, so I'm going to place. Yeah.